All right, today I'm going to use my beautiful artwork to help explain some math to you. This is a stick figure human being, and this is a flagpole, as if I have to even explain that. Now, yesterday I was showing you how to use shadows to make similar triangles to measure the height of this flagpole. Today we're going to use a mirror. Yes, the reflection. So we're going to pretend that the whole piece of ground here is a mirror so that you can look into the mirror and see the top of the flagpole. Now you have to look just in the right spot. You know, the reflection of the top of the flagpole is going to be somewhere in here. Let's just say it's right there. So if you're looking, I don't know why I wrote right there. Whoops. Time to get a new marker. Ta-da. All right, if you're looking, say, right here, and you can see the top of the flagpole right there in the mirror, that means your eyesight is on that line, and the reflection of the top of the flagpole is going to make the exact same angle, even though they don't necessarily look that way in my drawing, which is no longer beautiful art because it's not perfectly symmetrical. Sorry for that. Plus, I drew the eyeball kind of like on top of the head. Should be down a little bit. So forgive me. I'm a math teacher, not an art teacher. All right, back to the problem. This reflection, we had a problem like this yesterday with the hockey puck. You hit, or a lot of times you'll see a pool table as these kinds of problems where the hockey puck or a ball on a pool table bounces off the side at the same angle that it hit the side. Light works the same way. Light will reflect at the same angle that it hits. So these angles are the same, therefore these triangles are similar because they're both standing at 90-degree angles. So you've got two equal angles, angle means similar. Now you can measure how far away is this reflection point from the flagpole. We'll say 15 feet. How far away is the person from the mirror reflection point? We'll say 10 feet, person's 6 feet tall. And that's enough information now to figure out how tall is the flagpole because we have similar triangles. We've got a triangle with two sides known, so I'll use those two to make my first fraction. And then the second one, I'll match it. I did side to bottom, so I have to go side to bottom. The side is the unknown. The bottom is 15. Then you cross multiply and you get 90 is equal to 10x. So the flagpole is 9 feet high, 9 feet tall. Okay, there's one more method for measuring distances that would be otherwise difficult to measure. They don't always have to be going straight up in the air. They could be going straight across, say, like a river. So let's say you and your friend are stranded on opposite sides of a river. Here's one of you. Here's the other one of you. And you need to know how far across the river is it, because you can only swim for so far. So you need to know how far across the river it is. What you do is you pick a point right on that river here, and you pick another point over here, and you imagine connecting those with a straight line. And then you pick a point on the river and a point, and you go perpendicular to the river so that you make a 90-degree angle with the river, and you come all the way down until this is a 90-degree here. What you've done is, well, really they should cross right at the edge of the river. So it should be more like this. What you've done is create two similar triangles. You've made a right angle, so they have this little triangle and this big triangle. Each have a right angle, and you've also made vertical angles. This angle right here and that angle right there at the edge of the river are also equal because they're vertical angles when two lines cross. So you have similar triangles. You just have to rotate one to get it to match up with the other this time instead of reflecting. And now this little triangle, you can measure the sides of this little triangle, and your friend over here can measure how far away they are from this point. So you say go, start measuring, and your friend measures, and they're 20 feet away, so that's 20, and you can measure this distance here. We'll say that's 8, and this distance here is 12. Now that's enough to figure out the missing side of your triangle that you want, which is the distance across the river. Nobody even had to go swimming or throw a rope or anything across the river. You just measured things on your own side, and you could figure out how far across the river it is. It's kind of cool. So I'll use, when I set up my proportions, the same triangle so I don't mess it up. So I'll use 8 over 12. And then what side corresponds to 8? It's the straight side going across the river. It's this one right here. That's what we want to know. So it'd be side to bottom. This is side to bottom. So x over 20. Then you cross multiply and divide. You get 160 is equal to 12x. And that's like 13 and I believe 1/3. 156, 4 left over. Yeah. So it's about 13 1/3 feet or yards or whatever your unit is. So it's all the same concept here. It's just similar triangles and using similar triangles to solve for a missing side. Sometimes your similar triangles will have to rotate to match up. They make vertical angles. Sometimes they'll reflect with a mirror, and sometimes one will be inside the other like a shadow if you're standing inside the shadow of something tall, like a light post. That kind of looks like a shower head, but that's rays of light coming down from a light post. All right, so 3 different ways, all the same concept.